Alright, let's take a look at amines. Okay, the general formula is a molecule, so an alkyl chain bonded to NH2, and we can have primary or secondary or tertiary amines, and it's determined by how many carbons are directly bonded to the nitrogen. For example, this is a primary amine because it only has a single carbon bonded to the nitrogen. This is a secondary amine, it has 2 carbons bonded to the nitrogen, and here's a tertiary amine with 3 carbons bonded to the nitrogen. Okay, the naming, primary is easy, propanamine or methanamine or ethanamine. I don't actually think the one's necessary. I'm pretty sure the naming always begins from the carbon with the nitrogen attached to it. Secondary, we call the longest alkyl chain is the base chain. So in this case, show this next slide. Yeah, okay, let's look at it here. So secondary, this would be a secondary amine. See, it's got 2 carbons attached to the nitrogen. The longest carbon chain is the base chain, so we call this ethanamine with a methyl group attached to the nitrogen. Okay, so hence the N-methyl. Okay, the methyl attached to the nitrogen. N-methyl ethanamine. So the ethanamine is the rest of it, and this is the methyl attached to the N. And again here, we had 2 methyl groups, so on either side, we call it NN dimethyl ethanamine. So again, the ethanamine is the main part, and then the 2 methyls attached to the nitrogen making it NN dimethyl ethanamine. Amines are polar molecules, which means that small amines are soluble in water, and they get less soluble as the carbon chain gets longer and longer. They have higher melting point and boiling point than general hydrocarbons because they have hydrogen bonding. The hydrogen bonding they have is weaker than in alcohols, and it's stronger in primary amines than it is in secondary. And there's no hydrogen bonding in tertiary amines because the nitrogen is not attached to a hydrogen. So the smallest amines are gases, and then 3 to 4 are liquids, and 5 plus are solids at room temperature. And amines are weak bases. Okay, so we're going to look at a few different reactions. We're going to look at preparation from haloalkanes, hydrolysis, acid-base reactions, reaction with acid chlorides, and reaction with haloalkanes. Okay, so preparation, we can prepare an amine by reacting a haloalkane, so in this instance chloroalkane, with ammonia in alcoholic conditions. So it's a substitution reaction where the halogen atom is replaced with NH2. And we see that over here. We've got the same molecule, but NH2 instead of Cl, and then HCl is a byproduct. Cool, so that's preparation. Hydrolysis is reacting with water. What happens is we split the molecule into an alkyl ammonium ion. So that's where we have the same, whatever the carbon chain was attached to the amine, from the amine. We have that same carbon chain with NH3 plus and OH minus. This is why amines are bases, because they produce hydroxide ions in water. Okay, acid base, ammonia. If we react ammonia, which is a base, with hydrochloric acid, HCl, we get ammonium chloride, we get a salt. Same thing happens with an amine. So let's take methanamine as an example. We react with HCl, we get methyl ammonium chloride. So instead of methanamine, we get, like we said back here, we get an alkyl ammonium ion, and we get the chloride coming from the HCl. So basically it's this gaining a hydrogen to become a positive ion, and the chloride joining that cation. So methyl ammonium chloride and the salt. Reaction with acid or acyl chlorides produces a secondary amide. and we're going to look at amides a bit later on. But for now, just know that if you react, and we're also going to look at acid chlorides, but this is an acid chloride, it has a carbonyl group and a Cl. If we react an acid chloride with an amine, we get HCl as a byproduct, and the nitrogen joins the carbon to form a secondary amide. Okay, and that's amines.